Hello.
My name is Ryan McKee, and this is Lab 4, Circuits.
The purpose of this lab was to study resistance.
Resistance and capacitors in circuits and to find the time constant of a capacitor light bulb circuit. The model I used was the CCK Circuit Lab. I also used the physical principles of voltage, resistance, and current.
During this lab, I found that it takes
Longer to discharge a capacitor than to charge it. I also found that the time constant of a bulb and capacitor circuit was 6.03 seconds.
The main physics ideas in this
This lab was voltage, which is the difference between electric potential along a circuit, and current, which is the motion of positive charges along a circuit, opposite to the movement of the electrons. Resistance is how difficult it is for the current to move along a circuit. Resistance is usually due to some object in the circuit causing resistance, or from natural resistance in the wire. I used voltage to calculate the time constant of the circuit.
In this lab, I assumed that there was no
Resistance in the wire. This was reasonable because I had the resistance in the wire set as low as possible in my model. I also assumed that the CCK current model was accurate. This was reasonable because the model is from a reputable source. I also assumed that the capacitor in the model had finished charging or discharging completely. This made sense because I measured the voltage using the voltmeter and ensured it was at a desired value before stopping the stopwatch. The desired value was either 9 volts or 0 volts, depending on if the charger was charging or discharging, or if the capacitor was charging or discharging, respectively. In this experiment, I first created a circuit with 2 resistors and 2 batteries. Then I studied the circuit and measured the voltage. Next, I built a system with a battery, bulb, and capacitor. I then charged and discharged the capacitor with different bulbs and measured how long it took. Finally, I found the time capacity of the capacitor bulb circuit by graphing the natural log of the change in voltage divided by the original voltage over time. In all of these experiments, the system was the circuit and the surroundings was the computer software and everything else. The initial condition was the circuit open with no current passing through it.
My lab showed that
Discharging
discharging
a capacitor takes longer than charging one. This may be due to the voltmeter showing more digits when it gets close to 0, making it take longer to reach 0. My voltage graphs are shown below. The voltage time graph is in blue, and the voltage along the circuit graph is in red. In order to find the time constant, I set the slope of the blue graph equal to -1 over the time constant. In other words, I found the negative reciprocal of the slope of the blue graph. This time constant was found to be 6.03 seconds.
in this lab,
The data was gathered from a model, so they are the same. In real life, resistance in the wires would have caused some discrepancies between the recorded data and the data that I found in my model.
some potential sources of
Error in
error.
this lab was the small number of digits in the instrument I used to measure voltage, as more than 3 significant figures would have made my data more accurate. My model also assumed no resistance in the wires, which is not reflective of real life, introducing error. Finally, as the volts approached 0, the voltmeter began showing the thousandths place. This increased the amount of time it took to show the capacitor completely discharged compared to the hundredth place measured while the capacitor was charging. This introduced error into the measurement.
If I was doing this
Lab in real life using an actual ammeter, the ammeter would cause some resistance in the circuit. This would decrease the amount of current that flows through it, lowering its reading. If I was not using a resistor and used just a battery to charge a capacitor, there would be a short circuit. In the ideal model, the capacitor would charge almost instantly, but in real life there would be small amounts of resistance in the wire. This would cause the capacitor to charge a little bit slower than in the ideal model. Thank you.